Alright, live. Picking up where I left off from last time. Top K frequent elements. Still on arrays and hashing. After finishing this one, should be about halfway finished with the first part of the roadmap. So let's see. Just want to go ahead and check out what other areas come up next. 2-pointers and stack. I'd probably just go ahead and finish up stack. Got 7 of those. So 10 in arrays and hashing, right? 5, 9, 16, and then so it'd be about 21 for the first 3 sections. Top K frequent elements. Given an integer array nums and an integer k, return the k most frequent elements within the array. The test cases are generated such that the answer is always unique. You may return the output in any order. Okay. So, k is 2. The k most frequent elements within the array. And integer k. I'm just trying to see what the purpose of this k is. K most, is it all the integers which exceed k? So that's why 1 isn't included, because it doesn't equal or exceed k. I mean, I think that's what it's asking. Given an integer array nums and integer k, return the k most frequent elements within the array. And then the output needs to be sorted. Or, well, it could be returned in any order, so it doesn't need to be sorted. Constraints. Num's length is greater than or equal to 1 and less than or equal to 10 raised to the 4th. Any numbers inside of the elements or inside of the array between negative 1,000 and 1,000. K and the number of distinct elements in nums. Less than or equal, greater than or equal to 1 and less than the distinct number. Time and space complexity. You should aim for a solution with big O of n time and big O of n space, where n is the size of the input array. So again, I mean, this is the arrays and hashing section, so we're going to be looping over an array and storing the results in a hash map in order to track what we need to. And also I'm getting, like, I want to try and see if I could just intersperse these problems, maybe just skip to the 2-pointers and the stack, maybe do half of them, and then also do the same for the rest of the sections, you know, get a better overview of all the problems and then work on the harder problems after having gone through all of them. It's not the recommended approach, but I feel like it probably would be a little bit more interesting to do it that way, for me personally. Well, I will, I'll just go ahead and start working on this one. I'll keep that in mind. Perhaps that is the approach I'll take. Top K frequent. Go ahead. Goal and the constraints. I'm just going to start working on all of the problems in VS Code because I typically always have to end up debugging a small little error in order to get it all working anyway, so might as well start out from here. Now that I've kind of worked through the initial issues I was having at first, which weren't really issues, but just me not having the setup correct. All right. Okay. Excuse me. Bad habit of mine. All right. Static. Import that. Top K frequent. Make sure that all runs. Okay, frequent. All right, it's running. Okay. So yeah, there's gonna be a loop. Gonna have a map. We can have negative integers again. So I think it was 2 some. We ended up using map because one of the potential inputs or elements inside of the array, the numbers, had the potential of being negative, and that caused my computation to be incorrect initially. So I'm going to just start out with using a map in order to keep track of these. And I mean, it's really going to be essentially the same thing, right? Storing it in there inside of the map with the number as an entry, and for const x or idx in nums. And then afterwards, we're going to be iterating over the map again after having stored all of the unique number, well, not unique, but the numbers inside of a map with the number as a key and the element being stored in the map being an array of all the individual occurrences of that number. Then loop over all the keys, check the array. If the array's length is greater than k, then that gets included in the final output array. Otherwise, it's excluded, and the loop over the rest of the keys in the map will just continue. get the key here. The key should be the number, should be. Key is a string. Let's see. I want to check if there's any methods. There's for each. I mean, that'll be. Wish I could see the full type signature of this. Okay, here we go. So we get a value. The callback function takes the value, the key, and the map. The callback function. Wouldn't make sense for the callback function to accept the entire map. I don't know. I'd rather there's just like an array.map for the map. So I can go over each key map iterator, returns an interval, key value pairs, every entry of the map. So yeah, perhaps that's the approach I want to take. Key value. We need to structure this. Yeah, I mean, not working with TypeScript. Well, just run with that. If value.length greater than k, then we'll go ahead and include the key inside of result. I've done it. You can do the mutable way or just reassign result, do a spread. I mean, the mutable way is always going to be more performant, I'd imagine. It probably is the case. Just go ahead and check that as well, since I'm paying attention to time and space complexity. JavaScript array spread big O performance versus array.push. Array.push, O1 big O, and the array spread, the ON. So again, that would just end up being another constant in front of the n. So really could use both. It would be a slight performance hit, but in this case, I'll just go ahead and run with push. Mutability, when it comes to just mutating something locally inside of a function, really isn't that big of a deal. But when you scale up and have a larger project, that's where it can start to bite you. So what was it? Oh yeah, I need to go ahead and add all the nums idx. We'll go ahead and add. Let me get that as x. So the individual number inside of the array, we'll only want to set it. This is if it already doesn't exist. So if I go to retrieve it from the map, the number from the map, using it as a key, already exists. y here, y is not equal to undefined. If this is true, then we need to go ahead and update the current. I'll call it XS instead. I need to go ahead and update it with the currently iterated index. In this case, again, this is mutation, so I'm assuming that the underlying array, since we should just kind of have a reference to it and not really have it by value here, and when invoking push, well, here, so I'm talking about XS, right, and then YS. So the immutable update, well, the mutable update is this, XS, right? And then I would expect XS to now have 1 in it. YS, if I was to, first I'll have to add 1 to it like that. So YS is there because I reassigned it. Now if I do a spread of YS and then 2, I would not expect the original YS to have 2 because it's immutably updated. It won't have 2 unless I reassign YS there. So in this case, retrieve the array from the map, pushing here, I would expect that inside of the map that is storing the array, that array is mutated and it's updated with value. So yeah, with that, if it exceeds, or well, is greater than or equal to. So I would believe that this should be working now. I mean, assuming I have all of the syntax correct. So I wanted to try and destructure the key and the value here. It seemed like returns an iterable key. So perhaps it'll be an array here that I'll need to destructure from. Okay, so that is running. Push into result. If the key exceeds, setting M. And whenever you set M, it is a mutable update as well, I believe. Invoking this correctly. IDX is a string. Just let's see. That's able to get key salt. Oh, meant to push the key there. That still wasn't it. Okay, so this is why I really like working with typed languages, because I tend to have a better idea of what values I have where. And the more that I work through this with JavaScript, which I don't know, for some reason I just assumed perhaps I'd have an easier time just working through these than using C#. Because I'm not that. I mean, I can use C#, and I definitely thought about it, but I wanted to use JavaScript because I had some projects in mind for, you know, some future streams that perhaps I wanted to work through. Although I wouldn't be just using plain JavaScript, I would be using TypeScript. But and if I could use TypeScript on here, downside is that I would have to go through and delete the type annotations every time I submit a problem. So that's why I wanted to just try and see if I could just use straight JavaScript. But this seems to be backfiring on me. I mean, that shouldn't be an issue. Well, let me go ahead and give this a shot. I'll just do the spread operation, update, and then actually go ahead and do a set with that. Just in case, nope. So okay, I'm gonna have to go ahead and just make sure that the iteration is actually using the expected IDX in nums, IDX equals IDX, and then it's possible also that this entries isn't doing exactly, unless this might be a function, and that could be a reason why too. Just make sure we have the correct values being iterated over. So it looks like no values are being added, or map isn't being updated at all. Yeah, that's how I updated map before. So I checked it was undefined before. So yeah, this isn't gonna work. I did iterate over it in, I think, valid anagram. So how do I do the iteration? Well, I guess it was just in 2, so I might use the map. Group anagrams. That's where I iterated over key in the object. Okay, I mean the map is having elements added to it, but it is still not iterating over any keys. The group anagrams. That was, yeah, it was just an object, so Let me go ahead and just do a Google search. JavaScript, iterate over keys of a map. For of with map.keys. All right. Oh, well, yeah. Would help if I changed that, eh? Value.length is undefined reading value length. Value is 1. Key value. How's the array of key value just that's being printed out just equal to 1? I'm doing, oh, okay. So here, I need to be using get. There we go. Alright, get rid of all the extraneous comments, console logs, and this should work. I still have a console log somewhere. Standard out. Result.push key. Oh. No. Yeah, that's right. Standard. Where's the standard out coming from? Oh, okay, right here. Thought I got rid of all the console logs. Okay, well, this output, I would expect, well, no, yeah, I was only including, if k is equal to 2, just because of the somewhat vague description or problem description here, I assume that, you know, given all the information that's available here, that if k equals 2, in this case 1 isn't included in the output array, so it's not greater than or equal to k, so it's not included. But there's 2's, and it's included in the output, so I figured if the value, if there's 2 of the unique 2 elements of 2 in the array, it equals the k, then it gets included in the output. And then there's 3, it's included as well, but this breaks that. Like, what is this? We've got 1 and 2, k is equal to 2, and the expected output should be 1 and 2. I'm not seeing a pattern here, because this is also the case with 7. K is 1, there's 2, it's greater than or equal to k, so we go ahead and output 7. Last executed case. Given an integer array nums and an integer k, return the k most frequent elements within the array. So, I don't know. I think this is an error. I'm not going to spend any more time on it because they're really, well, we can check out some hints, I guess. A nice solution would be to count the frequency of each number and then sort the array based on each element's frequency. After that, we would select the top k frequent elements. This would be an O n log n solution. Though this solution is acceptable, can you think of a better way? Count the frequency of each number, and then sort the array based on each element's frequency. Yeah, that hint is not helping me right now. Can you think of an algorithm which involves grouping numbers based on their frequency? Kind of think I did that with my solution. Use the bucket sort algorithm to create n buckets, grouping numbers based on their frequencies from 1 to n. Pick the top k numbers from the bucket starting from n down to 1. Okay. So this hint provides a little bit better explanation for what they actually want, which is k needs to be the total number of elements included in the output array. And it's going by the frequency, so I mean, kind of wish they would just include an explanation like that for what's actually expected. But so if we have input array, go to 1, 2, 2, 2, or well, 2, 2, and then the 3, 3, 3, and then 4, 4, 4, 4. And then k equals 2. In this case, the way that I wrote the algorithm before, the output would be 2, 3, 4. But based on this latest hint, the output, what the correct output should be is 3 and 4. A max of k elements should be included in the output array. Because the name was top k frequent, I had assumed that k was like a threshold value which needed to be exceeded in order for the element to be included if it had that many repeating, if it appeared in the array that many times, k times. So, and when they're talking about the bucket sort algorithm, they're sorting based on the frequency, and then you would, I don't know, if you're storing everything in a hash map, and then you're getting all of the lengths, and then you sort the length of that array from greatest to least or least to greatest, whichever order. If you sort it from greatest to least, you're going to take the first k elements of that array. If you sort it from least to greatest, you're going to take the last n elements of that array, or well, k elements of that array. So yeah, that third hint really provided the additional details that were necessary. So let's see, with my current approach, we're at I don't believe because we have a for loop over the array, so that's big O of n. We do another loop. It's essentially a constant, 2 of n, so you can drop that. We're still at O of n. We're just using a map to store everything, so we're at big O of n for space complexity. But they mention needing to do a sort over the length of well, the length. So every time I'm doing length in here, it's like I would be creating a second array to store all of the lengths, and then I would need to sort it here, but then that would lead to, they said using bucket sort, a big O of n log n uh, time complexity if I did that. So I would imagine there's going to be the need to have some kind of intermediate value again. And I don't know, I mean, I think, well, I do know it's going to be an array. Say intermediate top k frequent. Well, it can still be result, right? So if k, that's not what you want to do, so you just go ahead and get rid of that. We'll say if result is less than k, then we're just going to go ahead and push the value. Else, we need to go ahead and check. Let's see. Perhaps instead of an array, I could use a map. The idea is that I'm just going to store those k elements in this result, and then for each additional, I'll just probably use a map, and then I can transform it. So intermediate map. I'm just going to store the keys and the frequency, right? And then there's going to be another loop over this intermediate map in order to check it against the currently iterated value in the main map. And then whatever intermediate map has for its top k frequent, if it's exceeded by the current value length, so we do, well, it should be now intermediate m dot set key value, and then we're going to need another for const. I'll just call it key 2 intermediate m dot keys. And value 2 will be, I'll just call it frequency, just to be more clear. Will be intermediate m dot get key 2. And so if value dot length greater than frequency, then it can replace it. Otherwise, we should just not do anything with it. But you would only want to replace it one time, though. If it's greater than all of the current values that are stored in the intermediate map, then we would just end up replacing everything. So, well, I could just use a break to exit out of the loop early. But then also, so okay. Instead of using, let's see what I said, key key is going to be the number itself, and then value, well here, frequency is going to be value.length. That's what I meant to store in there anyway, not the entire array. So we'll go ahead and use the frequency as the key. Call this one frequency 2, or subsequent frequency. Intermediate. No, this should still be frequency, right? Yeah, just call it frequency 2. And then might as well move this up to here. So frequency 2 greater than the length of frequency. Well, no, you want if frequency is greater than frequency 2. Then we're going to go ahead and add frequency 2, well, replace frequency 2 with the currently iterated frequency. And then otherwise, and then we need a break. But again, this isn't good because the results may not be updated. Well, for example, doing this second iteration here over the keys of this intermediate map are not guaranteed to have, you know, for like this previous example, right? We'll have 2, 2, so say there's, you know, 2 and 3 stored there. And then we're iterating over 4 currently. Let's say 3 happened to be here before the 2 2s appeared. But we're iterating over 3 first before seeing 2 2. And 3 gets replaced in this intermediate map by 4. Instead, we would want 2 to be replaced, because then we would have, you know, 2 4 being the output rather than 3 4. So it's like I don't really know how that would have, because it isn't the entire array, I don't think there would be an issue with sorting this short. I mean, the technicality is a big O notation, right? It's not the entire nums array which is being iterated over. But k also, what they say, the constraints of k, it could be the number of distinct, so yeah. So k can be very large as well. So we can't just assume that we would have to assume that if we were going to use a sort on intermediate M keys, that the running time, if we had to use a sort, would be at worst big O of n log n. So really want to avoid a sort here. And that's why, I mean, I was trying to go with this approach to avoid that to begin with, but I mean, it would be nice if, let me just do a search real quick. Is there a JavaScript data structure which stores numbers in a sorted order. Stores numbers as a key in a sorted order and can be used to look up a value. Does not automatically sort the keys. Using array value key pairs with manual searching and sorting. So yeah, suppose that would be the approach, right? Go ahead and just insert everything in sorted order, and then we'll have it to where the greatest number, well, the greatest element that appears in this intermediate structure, well, intermediate array, which is basically storing a tuple. So it'll be frequency, greatest frequency, and then num least frequency num. And then you always iterate out from the start of the array. So you can make the safe assumption that as soon as the currently iterated frequency exceeds the frequency in the intermediate data structure, in this case the array, that go ahead and intermediate, that you can break out of the array and safely replace that value at that particular index. And then let me go ahead and just check. I'll need to ys dot, I'm gonna have to do another search. So JavaScript array index update at a update value at array update value at an index. What is the time complexity? Create a new array. That's probably going to be create a new array. If it doesn't use a copy, that's probably going to be a big O of n. Still wouldn't make us violate the time or space complexity. Well, the time complexity. Yeah, time or space in this case. Width. Alright, so accessing an element by its index is a constant time. I want to updating value at a specific index. This means that the time it takes to update a value at a given is the same regardless of the array size. You can directly calculate the memory location of the element using the index, allowing for immediate access and modification. Updating an element's value does not require any additional memory allocation. The operation is performed in place, meaning the existing memory location of the element is overwritten with the new value. Therefore, the space complexity is constant. It does not depend on the array size. So, yeah, okay, yeah, but just a straight up mutable way of doing it. Okay, so that plan should work out just fine. An index here, which I'm hoping it's not going to be like the map where where it turns it into, yeah, it should just be the index. There's no issue there. So go ahead and update intermediate XS with the index, and then place it with X, and then we can break. Now this should work. As long as I have my syntax right, as usual. So what happened here? If on result is not defined, oh yeah, result less than K. Really want to do intermediate M dot length less than K. And then while doing this initial, still using set. Okay, so we can get rid of that entirely. Just a few things that need to be updated here. Crucial to insert elements in the array from greatest frequency to least frequency. So we're automatically going to want to insert it into the array. However, the insert location does matter. This is a large array. So I mean, if we had to iterate over all the elements, this time though, we're iterating over a shorter, m dot keys. It's not going to be quite the length of nums. So, I mean, we could still assume that it'll still be quite large. And then this is, if I have to use an array in order, or another iteration over this intermediate array, in order to find the location where this particular element should be inserted, I think we start risking the chance of violating the time complexity requirement. I don't it's possibly what I think that would be big O of n raised to the second power. I think anytime you have an array and then an inner loop over a similar one, I'm pretty sure that's exponential time complexity. In this situation though, not really, not seeing a better way to go about it here with everything I have set up so far. Let's see, go back to what I had. on Google just a second ago. Find, insert. Yeah, they're using a sort each time. Sorted map. Find. And yeah, I mean, it said use the bucket sort algorithm to create in buckets grouping numbers based on their frequencies from n to 1 or 1 to n, and pick the top k numbers from the buckets starting from n down to 1. Let's just check out what's the bucket sort algorithm. Bucket sort algorithm, a sorting technique that divides elements of an array into a set of buckets based on their value range, then sorts each bucket individually, and finally combines the sorted buckets to produce the final sorted array. So this sounds really similar to like a merge sort, honestly. Elements are distributed into buckets based on their value, usually dividing the data range. So it's divide and conquer. When the time complexity L1 is desired, when to use bucket sort, assuming the number of buckets is appropriately chosen. Choosing the right number of buckets is crucial for efficiency, sorting within buckets. It has a worse time complexity. Wow. It wasn't the hint. Might as well go down this path. Bucket sort is a sorting technique that involves dividing elements into various groups or buckets. These buckets are formed by uniformly distributing the elements. Once the elements are divided into buckets, they can be sorted using any other sorting algorithm. Finally, sorted elements are gathered together in an ordered fashion. Now, because you're choosing the bucket size, I mean, one thing that I was thinking of as I was reading through this description was that, you know, perhaps we could just discard the lowest frequency elements. You know, if you don't need. Well, in this case, you do have to sort everything first, right? So, I guess that approach wouldn't work. I was just kind of thinking of, you know, based on the value of k, being able to identify elements which can be discarded in order to reduce the amount of work or elements that need to be, you know, that need to have the computation run over it. But I think that was a little bit presumptuous of me. I'm jumping it a little bit. So, create an empty buckets or lists and do the following for every array element. Or insert array I into the bucket n times array I. And sort. What's going on with this syntax here? I mean, because they said it was going to be the bucket's going to be a range. So, if you're saying there's going to be n buckets, like 5 of them, right? And then you're saying to use the index that's going to be used is by multiplying 5 by the particular element it still seems like you would end up having and you need. So yeah, let's see if the other article is a little bit more clear on how the uh, bucket ranges are decided and which sub array inside of the larger bucket array each particular element should be assigned to. Um, Assume the input array is this. If you take an integer as input, you must divide them by 10 to obtain the floor value. Make a one-dimensional array of size 10 and fill it with zeros at first. Each array slot serves as a bucket for storing elements. Insert array elements into the buckets. Elements are inserted in the following buckets range. Example code has buckets ranging from 0 to 1, 1 to 0, 2 to 3, all the way up to n minus 1 to n. Assume that an input element with a value of 0.34 is chosen. It is multiplied by size 10, get 3.4, and then it is converted into an integer. Yeah, so I mean, so yeah, this does. I mean, yeah, it's kind of like a histogram. So that one was a little bit more clear. The last one I want to see still is Wikipedia bucket sort. Is a distribution sort, generalization of pigeonhole sort that allows multiple keys per bucket. Computational complexity depends on the algorithm used to sort each bucket, the number of buckets to use, and whether the input is uniformly distributed. Yeah. And what's the worst? The worst case is O. I wonder what the worst case of merge sort is. Time complexity merge sort. Yeah, so it's a better worst time complexity. And since it did say with bucket sort, you could use any sorting algorithm. And perhaps this would limit the worst possible time complexity of the bucket sort. See how long I've been going. About an hour. Okay. I am going to pick up here next time.